Okay. So a spring has 50 joules of energy stored in it. When it is extended by 2.5 meters, what is the spring's constant? So there's two pieces of spring information. Don't confuse them. The force for a spring, F spring, is equal to Kx, and potential energy spring is equal to 1/2 Kx squared. Depending on the language of the problem, you will use one or the other, and well, sometimes both. Don't confuse the two. Forces are not energy. Energy is not a force. So depending on the language of the problem, it'll outline how you are to solve it. This one says, number 3 says, a spring has 50 joules of energy stored in it. So we're going to use PE spring. So we've got PE spring is going to equal 1/2 Kx squared. We know there's 50 joules of energy there, so it's going to become 50, the potential energy stored in the spring, is going to be equal to 1/2. We don't know the spring's constant, it's what we're looking for, but we do know that the extension is 2.5 meters. So that's X. So then that's what you got to find. So it's going to be 100 divided by 6.25, whatever that's going to be. 15-ish, 18-ish, somewhere in there. Anybody else? Anything you've done over the last couple days? The work energy theorem stuff from yesterday, the spring stuff from the day before. Is there anything anyone would like me to go over? Okay. If there's nothing, hopefully you've done the things. Today and tomorrow we're going to look at our egg bungee. I wanted you to have read this. Oh, sorry, is there something you want me to do? Okay. I wanted you to have read this, but I will talk through it briefly here. Here's the intro. Bungee jumping. Legitimately terrifying. And there's a lot of faith you have in a lot of stuff in order to successfully bungee jump. Bungee jumping would not be as safe as it appears to be without relying on some basic principles of physics, such as the conservation of energy and Hooke's law for springs. Safe bungee jump occurs when no one is injured. An exhilarating bungee jump is one in which no one is injured. The free fall lasts as long as possible, and the bungee jumper comes as close to the ground as possible without touching it. Or, in the case of doing it over a river, the person actually hits the river without hitting the bottom of the river. Maximum exhilaration. What you guys are going to do over the next couple days, Akash, put your phone away so I don't have to explain it again. You are going to use the law of conservation of energy and Hooke's law to determine how to build the most exhilarating bungee given the materials I'm going to give you. This is what is going to be set up. And I've labeled a bunch of the variables here. There is a bungee apparatus that will be set up in the rotunda on the second floor. When I did it off the third floor, no one successfully pulled it off, and I think that had to do with we exceeded the stretchiness of the bungees. So we're going to go back to the second floor, and this is going to be set up in the stanchions of the second floor rotunda. It'll sit there. Right now, if you've been looking at the leadership posters, anyone in leadership? No. The leadership poster, all over the white one with the mug of hot chocolate, that one's getting moved. This one's going exactly where that is. It'll sit in there, and beneath it, you've got the bottom of the river and the surface of the river. This is the river. It will be when I put water in. Here's the river. It's going to have water in it. I will cap it when we're done so it doesn't evaporate, because that would change the surface. But this is going to be set up there now. Well, after I release you, I'm going to go do this so that you guys can start taking the appropriate measurements. Here's your bungee. Well, the bungee apparatus. This will be the river. You guys are all going to be given 10 of these. I've got identical rubber bands. You're going to get 10 of them. and you're going to loop them together. You've never looped rubber bands together. You overlap them. You overlap. You pull one through itself, and you get something like this. You want me to demonstrate that again? Okay, I'll do it on the screen. You got two rubber bands. They're on top of each other. Well, let's go like this. You grab the bottom one, you pull it through the top one, and then you put it underneath itself, pull through, and you get a loop. Easy to undo. You're getting 10 of them. You will put them all together and get one large bungee. We're going to start with the ones in the bags because they're the newest. I'm not sure if these ones will fail. They're getting kind of old. So let's leave those there. So you're going to make yourself a bungee. You're going to do a bunch of, that is obviously not going to be long enough to reach the bottom floor from the second floor of the rotunda. So what your task is going to be is, based on some calculations you have to do, you are going to find out how much string, or ribbon, you need to add to make this the most exhilarating possible. And I put different colors. Maybe you want purple, maybe you want red, maybe you like yellow, maybe you want sparkly silver. This is formerly a Christmas ribbon box. The only thing you cannot use is the fishing line, because the fishing line will stretch. There's some fishing line in here, don't use it. Different colors. Red, blue, purple, silver, gold, sparkly, black, etc. Don't use, the sinew has some stretch in it too. So that's what you're gonna, that's the goal here, is to calculate how much you have to add. You're then gonna have to take, if you take a look here, there will be some ribbon that gets used up in the tying on the top end and some tying on the bottom end. You need to take that into account. So you're gonna calculate how long you need it to be, and then you're gonna have some extra so we can tie it to a particular point, and you're gonna create a little basket on the end. You need a rider. A rider needs to be part of this process. And so what you're gonna do is you're gonna make yourself a bungee jumper. I have Sharpies. Here they are. I have empty canvases. 6 riders. There are only 6. Don't kill your rider before you have a chance to throw them over the edge. Give them a backstory. Make them someone. Use your Sharpies, pick your rider, decorate them appropriately. The only thing you have to have on your rider is your name on the bottom, so that we know whose is whose when they go back in here and then back into my fridge. Until we throw them off the edge of the tunnel. Your baskets are sandwich baggies, so that if they die, their guts are contained. It would be gross otherwise. You can choose how you want this to be. You can have it tied around here, but it's gonna give you length. You can put a hole punch through here if you want and tie it to a loop. How you choose to adhere your basket to your bungee is entirely your call. In the past, an easy way to do this. I'll pull this guy out. If you want to use it, I've got a hole punch. An easy way to do this is you can actually hole punch it if you like, and then loop the bungee through there. I will leave that to you to decide how you want to do that with a hole punch if you want. This lab takes you through a whole bunch of calculations for this. You've got the depth to the bottom of the river. Yeah, we'll just leave it there. You got your rubber bag chain, your egg basket, and then the ribbon that you're going to add is this length right here. That SL on the screen there. Then it takes you through the process. Here's all the materials you're going to need. You're going to need a balance. There's one up at the front. You're going to need your egg. They're raw, because if your rider dies, we want to know. There's going to be guts everywhere. We're not hard boiling the eggs. You got lots of markers, masses. They're on the table at the back. We still have them from our lab from before. Meter sticks, they're over there behind Granavin. Rubber bands, they're over here on the table next to Diego. Sandwich bags, also next to Diego. Scissors, top drawer right here. I'll just leave the drawer open. You can grab what you need. A string and ribbon is on the table right there. And a tape measure. I have 2 of them. You'll have to take your turns with them. Here they are. This little guy, please be careful with them. I have had to repair this one at least once, maybe twice. 0 is the end of the metal. You don't have to go up at all. 0 is the end of the metal, though it's a little bit kinky. So you're going to have to figure out how you want to play with that. And we've got this guy here. Same idea. When you're measuring, make sure you're using metric, not imperial. And 0 is the end of this guy as well. So I got 2 tape measures that you guys can take turns using for various things, assorted measurements you have to take. And then you've got a procedure that walks you through it. You're going to make your chain. And then before you do anything with your chain, you need to find, because this is a rubber bands, you need to find the spring coefficient or the spring constant of your chain. You've done this before. You found the coefficient of a spring back when we were looking at the force of a spring. I can see some of the writing still on the wall. There's still a rubber band hanging there that you guys didn't put away. You've done the lab. There's the evidence. You're going to do it again, but not nearly as involved. You're going to add a mass to the rubber band chain. You're going to record the mass. You're going to hold the rubber band and allow it to hang vertically. You're going to measure the extension. You're going to find the spring constant for that rubber band chain. And it walks you through everything you need to do here. You're going to tie the sandwich bag with a meter stick. You're going to record the length, tape measure. You're going to start measuring jump height. You're going to calculate stretch distance. I even told you what kind of calculation to use here. So this one is an energy calculation. Then a string length that you need to add, measuring it all just one more time, and then depending on how quickly this goes, either end of day tomorrow or first thing Friday morning, or whenever we have class, first thing in class on Friday, we will do the drop. And we will see who gives their egg the most exhilarating ride without killing them. And then I've got some questions on the back that you will answer. How did your bungee work? If it didn't work as intended, what may have gone wrong? Sources of error. What would you do differently next time? Who was your partner? How was it working with them? Was the work divided evenly? Yada, yada, yada. Would you work with them again? So this is what, and you're going to hand in this whole package. There's no formal write-up for it, but you are going to rip this out and you're going to hand the whole thing in. I've got some videos to inspire and perhaps terrify. You're going to see an egg perhaps die bungee jumping. Old Physics 11. Videos. Okay, where are you, egg drop? There it is. Is there really only one in there? Oh well, here we go. Egg bungee. Buddy is dead. That was the best one, that egg drop right there. And that's the goal. That one was really good too. So there it is. That is when we drop, that's what you're aiming for. That was a couple years ago. I don't know if you remember any of them. Naya, Manuel Boada, Zane Ewert, I think, was in that class. Grads from a couple years ago. Yeah, 2 years ago. back when they were in grade 11. So this was 3 years ago we did this. So that's what you guys are doing. Are there any questions, comments, concerns about the task ahead of you? Okay. Then you're working in partners with the people who are twos or threes with the people who are present. Procedure walks you through it. I'm happy with how the procedure, I've rewritten it a couple times. I think I'm finally happy. Well, I am finally happy with how it walks you through it. I will be around to help with the calculations or any questions you may have. But now, just the first, I have to go set this thing up. So if you have no questions, I'm going to be gone for the next probably 20 minutes, getting all of this ready to go. And Mr. Roberts has graciously allowed us to use her class for this solo rubber. These are the rubber bands I want you to use, not those ones over there. One thing you don't want to do is once you've made your bungee, I don't know why I did what it is, but every semester students are like, oh, I got this huge long bungee, and they start stretching it. As you do that, you're actually changing the spring constant of your bungee. If you spend time stretching the thing out, it becomes less stretchy. It will change your results as you're going. So make sure you don't do that. And then when you go and calculate the spring constant, don't use masses that are too large. It says 50 or 100 grams. You should be fine 100 to 200. I don't think I have any 50s, but I've got some 100s. I've got some 200. Oh, I'm so small. Yeah, there's a couple 50s. But remember, when you're actually weighing these things, don't trust what they say. You actually have to weigh them. I've got one scale over there by the printer. I still have this scale, which I'm going to set up right here. And you've got your task. If there are no questions, on your market set giver, I'm going to go down to the river. I'll set up the river. Yes. I'll go with that. As long as you don't feel like that's unfair setup. Yeah, go for it. You're cool with that? When you're done with your egg, the safest place to put them is back in the carton. So do that. And then the whole apparatus, once you're ready, like, yeah, eggs go back in here. And then your apparatus, they just toss them on the desk here too. Put your name, guys, on the sandwich bag so that if the egg and the sandwich bag get separated, you still have your apparatus to go with your egg. Okay? There you go. You have what you need. I will be back momentarily. This is my name. Okay. The bungee apparatus is up. And the river is there. The river is there, and the apparatus is set up. Have you ever had a year where everybody did it? I have never had everyone do it. I have had a year where nobody did it. That was a rough one, but that was the third floor, which is why we're not doing the third. The 1 year, my students were like, third floor. They all failed. So they really did not want it. So they didn't realize that would be a really bad idea. Why are we on our phones? All you can do an egg drop to do in a day and a half. Get off your phones. You have a task to complete. None of you should be on your phone. Because if you look at the diagram vine right here on the front, like it's measured from the bag length is measured from where the bungee attaches to the bottom of the thing. I mean, so if you hang the thing, you'll get a realistic idea of, because there's no stretch in that bag. So you want the egg in there, you want it attached to your bungee, and you want to measure that length, stretch. So ideally under the influence of gravity. Oh, I have pencils. That's not you. Yeah, my good. Oh, my boss is great on that. And don't break your either. You know, forward for a while. Yes. That's all you got for it? Decoration for a dude? You drop it? Came broken? That's not sure. What else? While you were powering it? Do a different one? As long as we have enough eggs. Does everyone have an egg? So this guy's broken. We do not want him as a rider. Okay. You can chuck it out of. Are you guys ready to go? You guys would like the string already? Yeah, it's out there. Go, take my measuring tape. Go measure. Yeah, no, you actually have to go measure the stuff. That's why I set it up at the beginning of class. Make sure you got, so Vine was walking around with only one piece of the lap. Make sure you got the whole lap. So you got the diagram on the front that will clear up when you need to measure. Yeah, it's set up. It's set up so you guys can go measure. Go measure. Get that going. It's on the second floor. You'll see it hanging there. Look at the diagram, and then go look at the apparatus. Take your diagram with you. You've got about 15 minutes. That's enough time to take some measurements. In about 12 minutes, I'll take the. Okay, I'll say this. Before you guys go, make sure you've got your apparatuses ready, because the bell's going to go in about 15 minutes, and the eggs need to be back in that carton, and your apparatuses, I will put a container together for you. Throw them in the D-bin. Put your apparatuses with your names on the bag in the D-bin. You do not need to bring your apparatus to the measurement. No, it doesn't come with you. Yeah, we don't need to. We just need to measure. They're both out there. So just head out there and then. You guys are competing, so don't share measurements. There are two tape measures, and Spirit's got one, the other one's out there already. Anchor down and grab it. Alright.
class also. Return it here. So actual height was 574.
Okay, put your eggs back in the carton. Put your apparatuses, the bungee and bag in the thing. None of you got started on the ribbon process, so it's tomorrow. In the T-bin.
So actual jump height is
Eggs go in the carton, guys. Apparatuses go in the block DJ.
The 5 meters 20.
Yes. Egg in the carton. Apparatus in the bin. Meter sticks can go back on the side. And rubber bands you didn't use go in the thing. Masses go back in the bin you got them from. Make sure your name's on your rider and on your apparatus so that you can get it back tomorrow. Okay. And Friday morning you drop. That's right. Yeah, I've got 5 eggs. They're all back home.
our lovely Liam Payne.
All right.
Spend more time doing that.
What?
I get to spend the rest of my class
Threading?
threading.
Is that?
It's
a hairstyle.
On metal.
Oh, cool.
Yeah. Using the lathes.
Nice.
Oh, yeah, all the year ones are still trying to work on their
Okay, see you guys tomorrow.
tapping works on the blade. It seems.
What?
You want to sleep with me again? Yo! You want to sleep with me again? Did you sleep yet? Where's Mr. Dewey? Hey. What's up? My money. Where's my money? Where's that? What? Oh, you're right. I got it. Tonight.
Pretty hot. Who's your barber?
You said 18. Switch up, yo. Yo, car, you job 14 yet today? Me and Ruben are gonna drop 14 and a half percent. 14 combined or 14? I'm walking in the same. That's the same school? What the fuck? Freaking you over. Fraction vision. I said you're gonna walk in. You said you logged in yesterday. Yeah, I did it the last quarter. My defense was fine. I locked in on defense. Last quarter. I locked in. I locked in on defense. I locked in on 7 turnovers. Oh. Yeah, dude. Jerry had 4 in 1 game.
Okay, ladies and gentlemen, happy Wednesday afternoon.
Okay. Let us. Whoa, I'm still recording? Whoops, that's from physics. That's a long video.